Hello friends, today we are going to talk about the density of the water and how we will perform the density of the water or any liquid in the lab. So density of the water is nothing but mass per unit volume. Okay, and this is a physical property of matter. So a physical property can be measured without changing the chemical identity of the substance. Since pure substances have unique density values, measuring the density of the substance can help identify the substance, and density is nothing but mass of a substance that is going to be divided by the volume, and the unit of gas are commonly expressed in gram per centimeter cube for solids and gram per ml for liquids and gram per liter for the gases. And this is also an intensive property of matter. This means that the value of a density is independent of the quantity of matter present. For example, the density of a gold coin and a gold statue are identical, even though the gold statue consists of the greater quantity of the gold. This is in contrast to extensive properties like volume, the amount of space occupied by matter, which depends on the quantity of matter present. The more the matter, the larger the volume. Okay, so for doing the density of the water in the laboratory, we all know that density of the water is the ratio of mass and volume of water at room temperature, which is equal to 998.2 kg per meter cube. Okay, and that is approximately equal to 1 kg per meter cube. Okay, so and the density of water in terms of gram per centimeter cube is 1 gram. Gram per ml is 1 gram per ml. Density of water in terms of kg per meter cube is 1000, or it's 1000. Sorry, I was mistaken. And density of the water in terms of lb per feet cube is equal to 62.4 lb per feet cube. Okay, now doing this experiment, first of all, what we have to do is we have to take these graduated cylinders, and using the electronic balance, this is totally specific. I mean, for example, I have a graduated cylinder which is 50 ml. So what I have to do is, if I am going to do in this one, so first of all I will put this and take the initial weight. So for example, the initial weight here is 9.51. Okay, now to add water or any kind of liquid, what I can use is a micropipette and a graduate cylinder. So we will be doing for both. So let's pip it out, and this is a movable micropipette. You can change, and this lies from 1 to 5, okay, 0.5 to 5. Okay, now what I will do is tear and then add so the mass of the water is, so this was the mass of the, this was the tear weight, and this weight is around 12.86. okay, and this is with water. Okay, and we had teared it. Okay, so now we know that density is equal to mass per unit volume. Okay, so this is the weight with water, and this is the teared weight. Okay, already I have teared, I showed you. So the density would be 12.86 gram upon, and the volume of the water is 10 ml. So in terms of 10 ml, this is equal to 1.286 gram per ml. You can convert that into kg per meter cube also. Now, for example, I take this beaker and let's stir there first. Okay, now the weight of this is around 118.89. Okay, so there are two ways. Either you take this weight and then add water and take the difference of the, the added water weight minus the total weight of that. So what I am doing is stirring this up, and then I'm adding a 10 ml of the water. So this is 5 ml, Then I will add another 5 ml. So this is around 12.80 with the cylinder. This is with cylinder, which is equal to 12.80 upon 10 ml. So this is equal to 1.280. There is a little variation from the, from the beaker, the cuvette that we use this one. Now we will do the same thing using a graduated cylinder. Now this weight is around this one. Now I will tear it, and then we would add this is around 10 ml. I would transfer this. So now with this cylinder, okay, so this is around 9.30 upon 10 ml, so which is equal to 0.930 gram per ml. Subsequently we can do the the density of the oil or the acids or other kind of liquid. So this was all about the density of the water or density of any liquid, okay, and how can we do in the laboratory. There are other methods also. You can use other other techniques to find out the density, okay, and even for it's not specific that you are taking the 10 ml, 20 ml, you can take 50, 10, doesn't matter, okay.